In this video, we're recreating the famous Loki Fireworks scene in visionOS, where Loki wows his date by conjuring fireworks from his hands. We'll build this inside visionOS, and along the way, you'll learn a ton of core visionOS concepts too. But before diving into any code, let's quickly talk about why do this. So we're tapping into something really ancient, the human urge to express emotions through movement and visual magic. From firelit dances that stirred ancient crowds, to magicians conjuring sparks from thin air, to rock concerts exploding with lasers and smoke, humans have always used light, movement, and magic to turn raw emotion into something you can see. And today, that same spirit lives on in the digital world. First with emojis, letting us express emotions in a single tap, and now through spatial computing, where gestures and effects from your own hands can bring feelings to life. Playful, powerful, and personal, just like this Loki effect that you'll be recreating. Let's get started. Great, so first thing, I'm going to create a new project. Make sure that's a visionOS project by clicking that, and then click next. And then name the project whatever you want, and make sure the initial scene is window and the immersive space renderer set to none. Click next, and save it wherever you want, and then click create. Awesome, so here we got a template starting project, which essentially shows a window with a sphere. So we're gonna get rid of all that, and here for now, we're gonna simply return an empty view. So this will show nothing. Great, so the first thing what we wanna do is we're gonna set up the basic setup needed for hand tracking in visionOS. So the basic setup involves two things. First, we need to make sure we ask for permission when the app starts for the user's hand to be tracked. That's number one. And number two, we'll make sure we're in an immersive space when we are running this app. In visionOS, there are essentially three different containers for viewing content. First, there's windows, stuff like this that you see in the previews. They display a 2D screen with content inside. And then there are volumes, which are essentially bounded containers for displaying 3D content. And then there are immersive spaces. Immersive spaces are essentially when you want to view full-blown immersive experiences. And for hand tracking to work, we need to run your app in an immersive space, and more specifically, in what you call a mixed immersive space. So within immersive space, there are three different modes: mixed, progressive, and full. And I won't go into the details, I've got separate videos on that. But mixed space is where ARKit based hand tracking, wall tracking, or any kind of tracking works. So you need to first set the permissions, and second, you need to run the app in an immersive space, more specifically in a mixed immersive space. Let's do all those now. So for that, I'm going to go to the starting point of the app, which is the Swift file named after your project name, this guy here, and it will be marked with this property wrapper main. So this is the entry point of your app. And here you can see at the moment, it displays a window group, i.e. a window, which in turn displays the content view here. I'm going to replace this window with an immersive space. And here, under the immersive space, we'll display the content view, which in turn, for the moment, shows an empty view, which will change later. Now for the immersive space, you can see there's the immersive style modifier. This essentially sets the style for an immersive space. And here you got a binding on an immersion style. And here you got the options for the immersion style that you want to support. So you can see again, there's full, mixed, progressive. So here you need the mixed immersive space for ARKit based hand tracking or any kind of tracking to work. I'm going to create a state var here. So state variable, call this immersion style, is mixed. And I'm going to bind this immersion style to this guy here. So $immersion style. So here what we essentially have is when the app first starts, it shows an immersive space. And here we made sure that immersion style is set to mixed, right? So that way we're showing the immersive space in a mixed mode, which supports hand tracking. Great, so that's that. And now we also need to set the permissions, right? First, go to the info plist, click plus here to create a new key. And here, the key name that you want is NS Hands Tracking Usage Description. Make sure you type that exactly correct. This would be of type string, and the value would be essentially the text that will be shown to the user when asking for permissions. So here you can write whatever you want, but I'm just gonna say, I need to track your hands to create some magic. Great, so that's the permission for hand tracking set. So now when the app first starts, it will show an alert asking for permissions to track the user's hand. In addition to hand tracking, because we're showing our app in a mixed immersive space now, we need to do one more thing. Under the application scene manifest, here you can see the preferred default scene session rule. It's set to a window. We want to change that to an immersive space application session rule. That will allow the app to run in an immersive space. Awesome, so that's the basic setup done. Next up, let's actually start implementing the whole firework effect. So for this, there are different parts to it, right? Firstly, there's the firework itself, which we'll use particle effects for. And then there's the hand tracking. And for hand tracking, we need to track two things, right? First, we need the position of the hand where we want to spawn the fireworks from. So that would be somewhere near the palm or the center. And then number 2, we also want to detect when the user closes or opens hands, right? So that would be like a custom gesture so that we could show and stop showing the fireworks appropriately. And then finally, we will also use spatial audio to actually have the audio of the fireworks in spatial modes. That would be a more realistic way of rendering audio. Great. Those are the different parts to it essentially. And now let's tackle it one by one, starting with hand tracking. So for hand tracking, first I'm going to create a new file. So new empty Swift file. I'm going to name this hand tracking. This is essentially the hand tracking model, which will essentially be a class that contains all the hand tracking functionality. So this would be class hand tracking, and we're going to import ARKit here because all the hand tracking functionalities come from ARKit. And then for this class, this would have a dependency on, say, an ARKit session, which we'll come to soon. And then it will also have a dependency on a hand tracking provider. So a hand tracking provider, this is the source of live data about the position of a person's hand and hand joints. So this is essentially a provider that ARKit provides, which will help you track the user's joints and their hand positions over time, which will help you also create custom gestures, as we'll see soon. So this is the provider that we need. It's hand tracking provider. And then we're going to form a constructor for this class, which will essentially take in an ARKit session, this guy, and take in a hand tracking provider and inject those into these values here. So this is just a box standard constructor in Swift where we inject the dependencies we need for this class. And in this case, it's the ARKit session and the hand tracking provider. And this class would essentially have 2 functions, right? First, there will be a function to run the session. So this would be an async function, a synchronous function. What this would do, it would essentially start an ARKit session with the hand tracking provider. We'll come back to that soon. But apart from that, we also need another function. We're going to call that process hand updates. And this would again be an asynchronous function. And in here, we would actually get access to the live data that would contain the joint positions in real time. And this is where we'll get our hand tracking updates from. So first, for the run session, what we're going to do is simply call the ARKit session.run. You can see this runs a session with the data providers you supply. So hand tracking provider is one type of provider. There's also providers for, say, plane tracking, image tracking, and all. Those are all different providers. And here what we're simply doing is running an ARKit session with a provider, which will do the necessary tracking for you. So here you can see run, and you can provide a list of providers in an array. And here what we're going to do is pass in the hand tracking provider. So ignore the error for now, but this would simply run the ARKit session with the hand tracking provider, which will in turn give you all the hand updates you need. You'll see that soon. This says call can throw, but it's not marked with try. So essentially this can throw an error. So what we need to do is wrap this inside a do catch statement. So we're going to do, and then we're going to try making that call. And if it fails, we're going to catch that error. We're going to do a fatal error for now. Of course, you won't do this in production. This is just for the sample app. So here we're going to say error starting ARKit session with hand tracking provider. Great. And then you can also display the actual error here. Great. So now we got one more error. This expression is async. It's an asynchronous operation. So we need to prefix this with await. Great. That should be the errors gone. And now we got the run session function ready. And that would simply start the ARKit session and configure it to do hand tracking. Great, so that's the run session function done. Now we need to call this from somewhere, right? So that we start the session essentially. So we're going to go back to content view, and here we have the empty view. Now here we're going to use the task modifier. This essentially adds an asynchronous task to perform before this view appears. So before this empty view appears, we're going to have an asynchronous task, and this is essentially to run the ARKit session. So we're going to use the function that we just created. So for that, I'm going to create a hand tracking object here with the class that we just created. So hand tracking, this would be hand tracking. And we need to provide this with the ARKit session and the hand tracking provider. So for the ARKit session, I'm going to create a new ARKit session here like that. Make sure you import ARKit for this to work. And then also for hand tracking provider, I'm going to create a new hand tracking provider object here. Great. So we simply created the hand tracking class that we just created earlier. And for the constructor, we passed in the necessary dependencies that we need, namely ARKit session and hand tracking provider, both coming from the ARKit framework, which helps you track your hands. Great. So now in the task modifier, I'm going to simply do hand tracking dot run session. Because this is an asynchronous function, I'm going to mark this with an await. That's what the error says. Awesome. So that's all the error gone. So this content view, when the app first starts, is displayed. It shows an empty view. And before the view appears, this guy here would start the ARKit session and configure it to do hand tracking. Again, later we'll replace this empty view with the actual reality view, which will display the 3D content, namely the fireworks that we want to display from our hands, but we'll get to that later. Awesome. So now going back to our hand tracking model, the model that we were creating. So here we finished the run session function, which would configure the ARKit session to do hand tracking. Next up, we're gonna finish up this process hand updates function, which when called, will start getting live hand tracking data, i.e. where our joints are and all that information that we need so that we could detect some custom gestures like open, hands closed, and also track the palm position over time. Great, so let's do that now. So inside this process hand updates function, what we'll do is we'll make use of the hand tracking provider here, this guy here, to get live information about our hands, namely the position of the joints and the hand skeleton in general. So let's do that next. What I can do is do hand tracking. This is the provider that we have, and you can see this anchor updates guy here, right? This is a sequence of updates for all hands that a provider tracks. So here's where we get the updates and the live information. So what I'm gonna do is loop over each update. So I can do it like for await and update in hand tracking dot anchor updates. And now inside here, we can loop through all the updates and do whatever we want. So here, what we're going to do is first get the hand anchor, and the hand anchor essentially has all the information about the hand skeleton and the different joints. And then number two, we'll detect the palm position, and then third, which we'll come to later, is detect if open or closed hands. This would be the custom gesture, right? So we'll use this information for essentially stopping and starting the fireworks, and we'll use this information as the spawn position of the fireworks. The way we'll approach this is we'll add the logic here, and then we'll pass this data to a callback back to our content view. And then we'll use these two information first to simply place a sphere on our hands and track it over time. And then we'll replace the sphere later with the firework using particle effects and all. So first I'm going to get the hand anchor. Quite simple. Let hand anchor equals update. So the hand tracking update here, and then you can do anchor. This guy essentially gives you the hand anchor, which contains all the information that you need. And now I'm going to do one more thing. Right now for this demo app, we're only going to track our right hand and we're going to ignore the left hand. So what I'm going to do is if hand anchor dot chirality, this is the value that indicates if it's a left or right hand. So if the hand is a left hand, I'm gonna ignore. So I'm gonna simply continue. So this would ensure for each loop iteration, if it's a left hand anchor that we're receiving the information for, we'll ignore that. That way we'll only be tracking right hand, right? Great, so let's leave that there. And next up, let's detect the palm position. Use the hand anchor, and here you can see there's a hand skeleton object, right? This gives you the current position and orientation of joints on a hand. And if you go dot there, you got methods like this one, joint. This retrieves a specific hand joint based on the joint name you specify. So for example, I can go here and look at all the different joints in your hands and get information about that. So it's middle finger, little finger, index finger, and there's a lot of different joints that ARKit tracks for you. Great, so now just to show you visually what all these different joints look like. So this is your hand skeleton, and in your hand skeleton, you got about 26 different joints that ARKit tracks for you using the hand tracking provider. So you can see it's like the wrist, the thumb, and the different positions within the thumb, the knuckle, the intermediate bit, the tip, and all that. And for each of the fingers, index finger, middle finger, ring finger, little finger, and forearm, you got different parts of those fingers tracked. Awesome, so it's nicely structured, and you can simply retrieve these joint data using the method that we were just looking at earlier, which we'll come back to soon. So in this case, what we want to do is essentially we want to find a joint and use that as the spawn position of the fireworks, right? So what we'll do is we'll use this guy here, number 12, that joint, to spawn the fireworks from. So number 12 is, what is it? It's hand, middle finger, intermediate base. So we're going to use the position of that joint as the spawn position for the firework. So I'm going to go back to the code. So here, what we can do is essentially from the hand anchor, we can get this hand skeleton, and from the hand skeleton, we can look for a joint named middle finger intermediate base. That's the joint that we were looking at earlier, which we can use as the spawn position. What we're going to do next is essentially get the position of this joint in world coordinates so we could use it in our app to position things there. I'm not going to do that here and make this function messy. Instead, what I'm going to do is simply create an extension on the type of this guy here. So this is of type hand anchor. I'm going to close this function, and just outside this class, I'm going to create a new extension. I'm going to make this private extension so that it's not exposed outside of this file. So private extension hand anchor. And in this extension, we're going to create a computer property. Let's call this spawn position. And this should return a SIMD3 float. So this guy here, spawn position, is a computer property. It will return an XYZ value, i.e. a SIMD3 float, which we could then use in our RealityKit content to spawn the fireworks from. Great, so now inside the spawn position, what we're going to do is First, we're going to get the join coordinates, and then we're going to convert that to world coordinates, and then we'll return it. So to get the join coordinates, what we can do is like we saw before, the hand anchor has access to the hand skeleton. So we're going to get the skeleton, and then from the skeleton, we're going to look for a specific joint. So this is joint, and the joint name is essentially the one we saw before, right? Which is the middle finger intermediate base, this guy here. That's the joint that we want. And now for this joint, what we want is this guy here, anchor from joint transform. This is the position and orientation of this joint relative to the base joint of the skeleton. So remember, this is not relative to the world, right? This is not in world coordinates yet. This is relative to the base joint of the skeleton. So we need to somehow convert that to world coordinates, which is what we're going to do now. So I'm going to name this guy here middle finger from hand. So this is the position of this joint, the middle finger joint, relative to the hand. So that's middle finger from hand, and we need to convert this to world coordinates. So to convert this into world coordinates, what we need is also hand from world. This is the position of the hand relative to the world. So for that, we could again go to the hand anchor, which is the entity we're extending from. So to that, self.origin from anchor transform. This is the location and orientation of a hand in world space. Now we got the hand position relative to the world, and we got the middle finger joint position relative to the hand. Now what we can do is a simple matrix multiplication. So what we can do is var middle finger position, and here middle finger position. Again, you can see Copilot is auto completing this for me, so I'm just gonna auto complete that. So here what we have is we're doing a matrix multiplication on the hand from world to the middle finger from hand, and this would give us in turn the middle finger position in world coordinates. Simple as that. So here we got a few errors. So this is of type optional, so we need to unwrap that. So what we can do is do guard let, and if that exists, great. If not, we're going to simply return nil. Great. Now that error should be gone. So we're also going to make the return type of the spawn position optional. Also, now that error should be gone. So all we did was we unwrapped this optional, and we made sure the spawn position computed property is also an optional, because there can be scenarios where it doesn't exist. Great. Awesome. So we got the middle finger from hand and the hand from world, and we matrix multiply those to get the middle finger position in world coordinates. Great. So now that we got it in world coordinates, if we inspect middle finger position, you can see it's a SIMD float 4x4, not the SIMD3 that we need. So we need to convert this 4x4 matrix to a 3-dimensional XYZ values, right? So to do that, let's see if it has XYZ conversion already. No, it doesn't. So what we're going to do is simply we're going to create an extension by 4 matrix value. So we're going to do extension float 4x4. So we're going to extend that with a method to convert a 4x4 matrix to a SIMD3 float. Great. Again, GitHub auto completes it nicely for me. So I'm going to auto complete that. So this XYZ function should convert the 4x4 matrix to a SIMD3 float value. So here I'm going to just do simply return SIMD3 float columns3.x, columns3.y, and then columns.3.z. Just explicitly add a self before each of these because we're looking at the columns of the 4x4 matrix. So self dot. Great. This extension function would simply return the XYZ values of a 4x4 matrix. So now we can use that back here. Again, what we're looking at here is we have a spawn position computed property, which would return an XYZ value as MD3 float. And here, after we got the middle finger position in world coordinates using this matrix multiplication, this is a 4x4 matrix. So we want to convert that to XYZ. So to do that, we can do simply XYZ like this. Again, this is the extension function that we just created here. And this would give us the XYZ value from the 4x4 matrix. Awesome. Now we can simply return this middle finger position. Return middle finger plus. Great. So now we got the spawn position computed property ready. This is an extension to the hand anchor, and we can use this easily in other places to place our content. So now we can go back to our hand tracking class, and in the process hand updates function, again, we're looping through each of the anchor updates. We're getting the hand anchor, and then here we're detecting the palm position, right? Let's rename this to the spawn position. That's more accurate. So here we want to know what the spawn position is. And for the spawn position, again, now we created an extension to the hand anchor, this guy here, which has a computed property giving us a spawn position. So for the spawn position, it's very simple here. We can do let spawn position equals hand anchor, and we can use the extension that we just created here, spawn position. Simple as that. Remember, this is an optional, so we need to unwrap it. So let's just check if this exists. So if there's a value for spawn position, great. If not, we're gonna throw a fatal error for now. Again, you won't do this in production. Awesome, so now we got the spawn position ready and we can use it for our app. So what we're gonna do now is we're gonna try and display a sphere at the spawn position. So essentially a sphere on the palm of your hands, which you can track over time. So let's do that now, just to show you that things are working and the spawn position for the hand tracking is working. So what we wanna do first is we wanna layer this information up to the content view, right? Because it's in the content view that we wanna display all the 3D stuff. I'm gonna go to the content view first. Right now we have a simple empty view with the task modifier, which runs then starts the hand tracking session. So now instead of this empty view, what I'm going to do is instead replace this with a reality view. So the reality view is essentially the view in SwiftUI that you use to display complex 3D scenes. So the reality view comes with the make closure, which is asynchronous in nature. And here is where you can do all the setup for your 3D scene. And the make closure comes with this content guy here. And the content guy contains all the entities for your 3D scene. So everything in Reality Kit is an entity, including invisible things and visible things like 3D models. So in our case, what we're gonna do here is in this reality view, we're gonna display a 3D sphere. So first I'm gonna create that sphere here. I'm gonna create a new computed property called this sphere, and this should be of type model entity. Again, remember everything in Reality Kit is an entity, and model entity is a type of entity that has a mesh and a material. So here for the sphere, I'm going to first create a mesh. So I'm going to call this mesh. And for this, you can do it like mesh resource and generate sphere with the radius 1. And now for material, I'm going to do a similar thing. Material, I'm going to create a simple material with the color red and its metallic properties set to false. And then using the material and the mesh, I'm going to create a model entity and return it like that. So this is a model entity created with the mesh and the material. Great, so this sphere computed property would give us the model entity that we could work with. Now back in the reality view, what I'm going to do is take the content, which contains all the entities in the scene, and there's an add method. This adds an entity to this scene, i.e. the content. So what I'm going to do here is add the sphere here. So what this would do is when this content view is displayed, it would show a reality view with the sphere placed at the origin. But right now, what we want to do is not place the sphere at the origin of the immersive scene. We want to place the sphere at the palm of the hand, right? i.e. the spawn position for the fireworks. That's where we want to place the sphere at. So to do that, first, what we need is we need the spawn position layered up to this content view, right? We'll have a state variable here, essentially inside this content view. Let's call this state var, say spawn position. We're gonna make this as an optional. And then what we wanna do is here, we're gonna have a new task. And in this task, what we're gonna do is call await hand tracking dot process hand updates. So this guy would start processing the hand updates and calculating the spawn position for each call. But at the moment, we don't layer that spawn position up to this view, right? So what we want to do is get the spawn position from inside this function up to this content view and assign it to the spawn position state variable. So that way that this state spawn position could be updated in real time. So let's do that. So we're going to go back to the hand tracking class, and inside the hand tracking class, again, if I collapse everything, you got the run session and process hand updates. And inside process hand updates, we go through each anchor and calculate the spawn position like this. Now what we want to do is layer the spawn position up to the content view. So we're going to do that simply by using closures. So here inside this process hand updates function signature, I'm going to add an input, and this is going to be a closure. So in this closure, we want to layer up both the spawn position and later on, once we've implemented this stuff, a Boolean value, which indicates whether it's an open or closed hands, right? We want to layer up both the information up to the content view in this closure. So I'm going to name this closure, let's call this on open hands detected. And this would take as input a Boolean value indicating whether it's an open or closed hands, the functionality for which we have not implemented yet, but we'll come to that later. And a spawn position, which is a SIMD3 float, right? So I'm going to do SIMD3 float, and then it will return void. I forgot the closing bracket here. Make sure you have that there. Great. So all we did here was add in a closure, and this closure will essentially have an input of a Boolean value, which indicates whether it's an open or closed hands, and a SIMD3 float, which indicates a spawn position. Now here, once we've calculated the spawn position, we can simply execute the closure on open hands detected. We're going to pass in a true value for whether it's an open hand or a closed hands. We're going to hardcode that in here now, but later we'll update that once we've done this bit. And for the spawn position, we're going to pass in the spawn position that we just calculated at this point, right? This guy here. So spawn position. So once we calculate the spawn position, we are executing that closure that's passed with this function with that position. Now what we can do is we can go back to the content view, and here now where we call process hand updates. So process hand updates. Now we get the closure here. So here we get the bool, which is open hands. And then we got a SIMD3 float, which would be the spawn position. By simply using a closure, we're layering up that information that we need back to the content view here. So here we're calling hand tracking.process updates, and from the process updates function, whenever we get an open hands detected or spawn position, we get that update layered up here. Awesome. So here we're using closures as callbacks. So now in the content view, what I'm going to do is open hands and I'm going to ignore it. We'll come back to that later. But the spawn position, I'm going to assign the state variable in this content view, this guy here, with the spawn position that we detect from the hand tracking model. So self.spawn position equals the spawn position that we get here. Awesome. So now the spawn position state variable will be updated in real time to track the user's hand position, namely the palm area where we'll spawn the fireworks from. Now what we're going to do is we're going to update this position of the sphere in real time to wherever the spawn position is, i.e. wherever the user's hands has moved. Great. So to do that, I can't do it here, right? This is relative view's make closure. This only gets called when the view is first constructed. Instead, what we have here is also an update closure. This, as usual, gives us the relative view content, which contains all the information about the scene. And then we got a closure here. And this closure is where we'll use to perform updates on the reality view. The make closure is asynchronous in nature and it gets only called once when the view is first created. And the update closure is we perform updates on the reality view or updates to our 3D scene. So in this case, we want to make updates to the 3D scenes whenever the spawn position variable changes. So whenever this guy changes, meaning the user's hand position has changed, we want to make it update in our 3D scene. Namely, we want to update the position of the sphere to match the spawn position. Great. So to do that, first, we need a way of identifying that sphere, right? For now, we're just going to do a quick hack. Just give the entity a name and we'll identify it by name. So what I'm going to do is here, when I'm creating the sphere and this computed property, I'm going to move that over here, the creation of the model entity. And then once I've created the model entity, I'm going to give it a name. With this, you can set the name of the model entity. And I'm going to name this, let's say, sphere. And now I'm going to return that model entity. So all I've done here is I've made sure the model entity that's created here has a name, which we'll use to retrieve in our reality view for our updates. Great, so the sphere, when it's added to the scene now, has the name that we can associate with it. Now here in the update method, to retrieve the sphere from the scene, what I can do is let sphere and use the content that comes with this closure and dot entities. Again, this gives a list of all the entities in the reality view scene. And from that entity list, I'm going to look for the first entity where the name is sphere. So shorthand way of writing this would be doing like this. First, $.0. So $.0, this would give each of the entities that this is filtering through and look for the name. And if the name matches sphere, then we return that as the entity here. Great. So this loops through all the entities in this relative view scene and looks for one with the name sphere. And then if we find such an element, we're going to cast this as a model entity. Great. So now if you hover over sphere, this should be an optional model entity. Now, because this is an optional, what I'm going to do is I'm going to unwrap it right here. So guard let sphere equals sphere. And if it exists, great. If it doesn't, return from this flow. So return. Great. So at this point, we've accessed the sphere from our reality view scene. And now what we're going to do is we're going to update the position of the sphere to the latest spawn position. So I'm going to do sphere dot transform dot translation. Again, this is the XYZ value of the sphere, and we're going to update that to the spawn position. So the spawn position is where we want to spawn it from our hands, right? So because spawn is a type optional as well, again, we got to unwrap spawn position too. So guard let spawn position equals spawn position, and if it exists, great. If it doesn't, return. Awesome. So great. So all we're doing here is we're one, retrieving the sphere, and then number two, updating the position of the sphere to match your hands. So the hand position is the spawn position here, which gets updated in real time by the hand tracking model that we created earlier. So this way, the sphere should track alongside with our hands. Now, the last thing we want to do is obviously add updated sphere to the content, right? So what we can do is do content.add the sphere. Great. So what happens here in this update closure is every time the spawn position guy would change, this update closure gets triggered because it contains reference to that spawn position, which is marked with state. Anytime the state changes, the update closure gets triggered. Once it gets triggered, we retrieve the sphere and we update the position of the sphere with the spawn position, and then we add the updated sphere to the scene. Simple as that. Awesome. Now to build and run this on the device, make sure you select the target to your Apple Vision Pro. This lets you run the app on the device, and then just click the play button, and that should build and install the app onto the device. Awesome. So now you can see when you first install the app, it's asking for permission to track your hand movements, right? This is again what we added in the info P list. We added this message, I need to track your hands to create some magic. So now you see that pop-up alert appearing, and now you can click allow. Awesome. So now as soon as you click allow, you can see the sphere is being tracked, right, with your hands. Great. So that's the spawn position working correctly. It's tracking our hand position where we want to spawn the fireworks from correctly. So instead of the sphere, later we'll have the fireworks spawning from this position. But before that, we need to do one more thing. From the hand tracking provider, we also want to know when the hand has been closed or opened. And when the hand's closed, we want to get rid of the sphere. And when the hand's open, we want to show the sphere. And later, when the hand's closed, we'll stop the fireworks. And when we open the hands, we'll play the fireworks. So to do that, we're going to design a custom gesture, again in the hand tracking provider. We'll have the custom gesture detect when the user's hands are open or closed. And based on that, we can show or hide the sphere now and later the fireworks. Great, so let's do that next.